All right, so let's prove a theorem about the image real quick. Let's actually go back up and look through our examples. The identity map had image R, and let's note that R is a subring of R. R is a subring of R. The Frobenius had image F2 adjoint x squared, which it just means polynomials in x squared. And we've seen that that's actually a subring of, well, polynomials over F2. The complex conjugation map had image all of C. C is a subring of C. The image of the evaluation map had image all of Z. Z is a subring of Z. So what we're going to prove in this theorem is that that pattern continues. So suppose you have a ring homomorphism, which I'm again abbreviating as ring hom for short. Then the image is a subring of what? Well, of S. And let's prove it. All right, so we're going to apply the subring test. If you've forgotten the subring test, go look at it real quick to make sure we're doing the right thing. So we first are going to show that it has the identity. We need that the 1 in S is in the image. But phi is a homomorphism. And all ring homomorphisms send 1 to 1. In particular, the 1 in S is an output of phi, so 1S is in the image of phi, because it's phi of something. Great. So we have 1. We now need to check it's closed under subtraction. So let's take 2 elements in the image. So let's say S1, S2 are in the image of phi. Well, by definition of being in the image, there has to exist some two elements. There might be more than 2 elements, but there exists at least 2 elements in the domain, such that well, phi of R1 is S1, and phi of R2 is S2. That's what it means to be an output. Then the difference S1 minus S2 is phi of R1 minus phi of R2 is phi of R1 minus R2. And that's certainly in the image. It's phi of something. So the difference of S1 and S2 is phi of something, so we're good. So the image is closed under subtraction. And the very last thing we have to check is closure under multiplication. So again, suppose S1, S2, R1, R2 are as before, so I don't have to rewrite that out. Then S1 times S2 is, well, S1 is phi of R1, S2 is phi of R2, but phi is a homomorphism, so we can break it up under multiplication, but we can also bring it together under multiplication. Equals goes both ways in math. So is S1 times S2 phi of something? Yes. So the image of phi is closed under multiplication. Okay. So what do we conclude here? Well, by the subring test, the image is a subring of S. So the subring test, again, is very important. It's always good to have it in the back of our heads. Okay, so the kernel is an interesting subset of the domain that tells us information about whether or not we're a monomorphism. And the image gives us an interesting subset of the codomain. The image gives us a subring of the codomain. And it will always, 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 always be a subring of the codomain.